Again, welcome to Python programming language. In these lectures, we're going to focus on how to write user-defined functions or how to write functions using Python. So that's a Python user-defined functions. So we are going to start with an example, the reason why, again, functions are very useful in Python programming language. So here, for example, we want to find a sum of integers from 1 to 10, also from 20 to 37, and from 35 to 49. If we don't write no function, this means we have to write the code, different code to find 1 to 10, another code to find 20 to 37, and another code to find 35 to 47. Now, if we write a function that can find a sum of any numbers, this means we can call the same function 3 times in the main function. And we can use that function by finding the sum of different range of numbers. Example here, 1 to 10, 20 to 37, and 35 to 49. So we are going to see how this works. So this is the problem. We want to find the sum of numbers from 1 to 10. So we use the for loop, the range from 1 to 11, which will give us the sum 1 to 10. Now we are writing the same code again. This time we are changing the range of values from 20 to 37. That's the sum from 20 to 37. Also, we are changing the third time. The same code, we are rewriting it again, but we change the sum from 35 to 49. So imagine if we have up to 20 or 100 different values that we have to find the sum, which means we have to write the code 100 times. This is one of the advantage, excuse me, of Python programming language. So again, this is the problem. We write separate code for each sum. We find the sum 1 to 10, next 20 to 37, next 35 to 49. Now, this is the solution. We are going to write only one function. Then we are going to call the function 3 times in the main method or the main function. Again, we shall go through the syntax or the structure of a user-defined function. Normally, a user-defined function have what we call the function heading. So we start with the keyword def, then the sum is the function name. Every function sometimes need a message or need information to perform some task. So here the function will need the values ranging from I1 to I2. I1 to I2 can be any value. So that's why we're able to call this function 3 times in our main function. So for example, the first function we call the sum, I1 is 1, I2 is 10. The second time we call the sum function, I1 is 20, I2 is 37. The third time, I is 35, I1 35, I2 49. So this is one of the advantages of using a user-defined function. Now, we can have over 100 or any amount of functions or of tasks that we have to do. All we need to do is call it as many times as we want. But we write the function only once. So again, we shall go through the details about the structure of user-defined functions and the syntax. So our main objective, again, we are going to study how to define functions, also how to invoke value returning functions. We have two types of functions invocation. So in this function, we can see that it's going to return a result, return result. So the result of a sum of all the value within the range. Then also we can invoke a function that doesn't return the values. For example, I can write a function to print a statement, which means I don't need any returning value. So we're going to discuss about that also, the syntax. Then also we're going to determine the scope of variables, the modules for reusing functions, etc. So let's start with the defining functions, our first objective. Here we say that a function is a collection of statements that are grouped together to perform an operation. So we can see the function sum. We have a group of statements. We have a for loop. We have a expression to add some values. We join all those statements together and they perform a specific task, which is to add the numbers from one range to another. So every function, again, consists of a collection of statements. Sometimes it can be only one statement. Let's say I can write a function to print an output, only one output. It's still a function. So a function is a collection of statements that are grouped together to perform an operation. Now let's look at the syntax. So here we have a function named mass. That's the function name mass. Then the formal parameters, that will be the information or the data the function need to perform its task. Here we have num1 and num2. So this, which means the function mass takes two parameters or takes two values. And also we call this section as the function header. We use the keyword def, the name of the first space, the name of the function, and the function. If the function will have no parameter, then we leave it as an empty parenthesis open and close. We still have to have a parenthesis. That will tell Python that this is a function. So if I write only mass with no def keyword, no parameters, it's more or less a variable to Python. So after that, we use a column to end it. And as usual, this is a Python. So we tap in and we write all the items we have here belongs to the function. So that's called the function body. This is all the group of statements. So when we look at this function, it's going to take two arguments and it will tell us which of the value is bigger. So here we have num1, num2. We check if num1 is greater than num2. If num1 is greater than num2, then we return num1. Else, which means if num1 is less than num2, then we return num2. Then we return the final. We put the result num1 into a variable named result. So if num1 is greater than num2, then num1 will be a result. So if the condition is true, we are going to skip the else section, then we'll return the result, which is num1. If it's false, then we execute the else section, which means num2 will be assigned to result, then we return result. Now in the main method, we are going to invoke the function. So here we have mass, x and y, we assign to z. Z will be the result that it will get, we assign to z. So again, s and y can be any value. We have 5 and 10. 5 and 10 means it will return 10 because the first value num1 is 5, num2 is 10. Is 5 greater than 10? No. If not, then return 10, which is num2, the second value. So that's what we said. The function header consists of the function name and also the function parameters with the keyword def. And the function body is where all the statements are. So here we say a function contains the header and the body. The header begins with the keyword def, followed by the function's name, and then the parameters followed by a column. Then we have the parameters, the formal parameters. That's the variable defined in the function header is known as the formal parameters. So num1 and num2 are the formal parameters. The function name again is mass. So everything is called the function header. Now the actual parameters will be when the function is invoked, you pass a value to the parameters. This is referred to actual parameters. So the formal parameters will be in the function heading. When the function is called in the main method, it will have the actual values. This time it won't be a variable name no more. So here x and y will be our actual parameters. Again, we are going to see an example soon. Also, we have the returning value. Normally, a function may return a value using the keyword return. So here we return 0. As we said earlier, also, we may have a function that doesn't expect no returning value, so we don't use no keyword return. So let's see an example. We're going to test the mass function, which we just saw. So now we can see how the program starts. We start with our function header. The function name is mass. It takes 2 parameters, num1, num2. This is again called the formal parameters. We end with a colon. Then we check the condition. If num1 is greater than num2, then return num1. So we assign num1 to result, then we return result. Else, which means the condition is false, then we are going to return num2. So we assign num2 to result, then we return the result. Now this is our actual parameters. We say I equal to 5, j equal to 2. So when we call the mass function, or we use the term invoke, when we invoke the mass function, we assign I and j, which means the first value is 5, the second value is 2. And this we call the function. So when we call the function, this function again will give us k value to be 5, because the function is again returning the maximum value. So the maximum value will be 5. Then again we print the result. The maximum number between 5 and 2 is whatever value is in k, which will be 5. And we write the main method here is to call the main function. So this is the syntax. Again, let's go through the animation. So the animation, the first thing, the program will be load, or the program loads the definition for the mass function to the memory. So right now, this is in the memory that we have a function. Anytime we come across the function mass, we have to refer to this section to do the work. So next, we go to the main method. The main method is where the execution will take place at. So first, we saw that I equal to 5, j equal to 5, the main function is called, the mass function is called. So this will be also loaded to the memory. Then our last section, this is where the program will start execution. So we have the main method called the main function. Now when we call the main function, which is here, we assign the first value to be 5, which is I. Second value, j, is 2. Then we come across a mass function. So this will go back to get the mass function execution. So here we are saying that in Python, an integer is stored in an object. Will number 1 or num1 and I reference the same object when invoking m? So our answer should be yes or no. So what we are saying here that in Python, an integer is stored in an object. Will the num1 and I reference the same object when invoking? And we say the answer is yes. So yes, because we assign I is the first and num1 so it's first. So okay. Now the mass function is in invoke. We have a 5 and 2 as I and j. So I and j are passed as num1 and num2, the reference. So we do the execution. Is 5 greater than 2? Yes. Num1 is assigned to result. So we return the result, which will give us again 5. So the output will be the maximum between I is 5 and j is 2 is 5. So as we saw the calling functions, and this is the program again. We have a main method. This is our last main method statement in the program. This is where the invocation starts or the calling process starts. So the main method will activate the main function or the main function. And from there, when we go through this code, we can see that the mass function is called. This mass function also, we go back to the memory. Then all the execution will take place here. We have ing, so 5 and 2 will be assigned to num1, num2. Then we do all the execution. We return the result back to the function. So in this case, 5. Then we move to the next step because the execution gets start from up down. So we start with 5 assigned to I, 2 assigned to J. We call the function, we do all the execution, we'll return the result back to the function. The answer is 5, so we go to the next line, then we print the maximum between 5 and 2 is 5. K will be 5. So that's the process again. We invoke the main function. Then we go to the main function. The first value I is 5. J is 2. Then we invoke the mass function. So that will take us to the mass function. Then we run the steps. And we check the first is num1 greater than num2, yes. If that is true, the result is 5. So we return 5 to the mass function, the main function. So that means everything here will be 5. Then the next step, we print our statement. Then we return back to the caller. Now let's see some functions with or without a returning value. So this function here, what it does is that it will check the score you have and it will assign the grade to you. The score shouldn't be between 0 to 100, it should be between 0 to 100. So here we say that if a score is greater than 90 or equal to 90, we get A. So somewhere between 100 to 90. As if it's greater or equal to 80, B, greater than or equal to 70, C, greater than or equal to 60, D, else printf. Now we know that in the syntax if elf, what this does is that if one condition is true, it will print it, then it will not print the rest. So we start from greater to lesser. Because if I have 89, of course, 89 is greater than 60, 89 is greater than 70, 89. But all this will not execute because it will start from the beginning, the top. So if the top, the condition, let's say I have 95, 95 greater than or equal to 90, yes. So we print A, we stop. We are not going to check the second condition. We are not going to, or the program will not check. Other than that, then we say, okay, it's 95 greater than or equal to 80, then we print B. And no. When one condition is true, we come out of the method because it's a LF. That's how the syntax is. So next, we have the method that again assign a grade letter, depends on the score you have. Now we come to the main method. First thing we do is that we ask the user to enter his score. So we use the input function, enter a score. Now, since we are going to compare the score with some value, of which we can say a comparison operator, greater, lesser, equal, we need to convert the input as a string to a float or to integer. So it can be float or integer. So we get the input, let's say the score is 70. 70 is a string with input. So we use the float to change it to decimal value, then we assign it to score. Then we print our statement here that the grade is, it will be at the end, print grade, the score. So the score we get here depends on what we enter. So here we are going to invoke the main method. So what will happen? Let's say the user enter 85. When the user enter 85, we are going to print first the grade is, then we hold on first. We call the method print grade with 85. So we come here, okay, print grade 85. So score is 85. We check the first. Is 85 greater than or equal to 90? No. So we move to the next line. Is 85 greater than or equal to 80? Yes. So we print B. Then we come out of the again the method print grade. So let's see the animation. So first thing we're going to do, we are going to load the definition of the print grade function to the memory. And the same thing applies to main function. We load it to the memory. Then now we call the main method or invoke the main method. When we invoke the main method, we come to the main method. We ask a user to enter a number. So he enters score. I'm going to enter 85 and I'll click OK. So our variable score is 85. So we print the statement, the grade is 85. Then next we came across a print grade method, which we already loaded into the memory. So here, does the function print grade score return a value? Our answer should be yes or no. When we look at this method, we don't have no returning key. So our answer surely will be no. And they say you are correct. This is a void. A void function means a function that does not expect a returning value. It doesn't have no returning value. So the statement will be invoked for print grade. And the score we have for beginning is 85. So we check, is 85 greater than or equal to 90? No. We move to the next condition, is 85 greater than or equal to 80? Yes. Yes. So if it's yes, we come and print the score 85. So the grade is B. So we print the grade is B. And that will be the conclusion of the program. We want to run it one more time. So next one is the same concept, but this time you can see we return something. So instead of printing the A, we say return A, return B, return C, which also will work. The structure of the program is the same, everything is the same. But this time, instead of printing the score directly, we are returning the score back to the main method. So you can see that the grade is will be printed. So we enter the score, then we print also the grade. So let's start again. Again, we load as usual. Previously, we loaded get grade. We also load the main method. Then we invoke the main method. And that will start from the main method header. And now the access, we should enter score. This time I'm going to enter 74. Click OK. Then here they say, does the function grade score return a value? Yes, because we can see anytime we have a condition met, we return the letter. Instead of printing it, we return it. So either we can print it in the user-defined function get grade, or we can return it to the main method and we print it. So you can see that here when we return, the function is called inside the print method so that we can print it in the main method. Previously, the function is called not in the print method because the print is in the get grade method or function. So I can say print A, print B, print C. Then I'll just call the grade, get grade function. So here, of course, the answer will be yes. So you are correct. This is a value returning function. Again, a function that does not return a value is called a void function. So you check our first condition. Is 74 greater than or equal to 90? No. So we move to second condition. Is 74 greater than or equal to 80? No. We move to the third. Is 74 greater than or equal to 70? Yes. So which means we are going to return C. So when we return C, then we're going to print the rest. The grade is C. So as we said, a non-value, we say a function that does not return a value is known as the void function. As we said earlier, in other programming languages such as Python, C++, and C#, but in Python, such function return a special value, none. So here we have a function named sum, takes two arguments, num1, num2, and then we had the two values. When we had it finished, we print the result. So this function does not return a value, it rather print it. Also, we can pass argument by position, which is very important. So we have a function named n_println. It takes two arguments, message and n. And what it does is that it uses the for loop. The range will be from 0 to n, which means if n is 5, it's going to do something 5 times. If n is whatever value it is, it will do it because it's starting from 0 instead of 1. Then we say print message. So what this will do is that if the message is Charles, it's going to print Charles 5 times. So here we say, suppose you invoke the function using welcome to Python. Yeah, welcome to Python is a string for the message. Then 5, which means I'm going to print welcome to Python 5 times. And the question here is, what is the output? The output will be welcome to Python 5 times. Or we say message n. And we start the range from 0 to n. Now, next we say, suppose you invoke the function using n_println, computer science, and 15. This means we are going to print computer science 15 times from 0 to 15. Now here we say, what is wrong? We have it opposite. We have the value for computer science. This will not work because we pass the argument by position. Message is 4, n is computer science. But to use the for loop, there have to be a whole number. Computer science is a string, so 4 will not be there. So what is wrong here is the position. Computer science should come first, because unless we change the position here, we say n is first, message is second. So it's the position changes. We can also pass by value. So we have a function. Pass by value means we pass by actual content of the variable. We can also have a function whereby we can pass by reference, which means instead of using the variable content, we use the variable address. The advantage of that is that if the value is very big, it will take more memory space than if you are using the reference address. But if the value is very small, then passing by a function by value, it's okay as passing by reference address. So here we say in Python, all data are objects. A variable for an object is actually a references to the object. When you reference on the object, you are using the address. When you invoke a function with a parameter, the reference value of the argument is passed to the parameter. This is referred to as pass by value. We are using the value. For simplicity, we say that the value of an argument is passed to a parameter when invoking a function. And precisely, the value is actually a reference value to the object. Now, if the argument is a number or a string, then the argument is not affected, regardless of the change made to the parameter inside the function. So let's see an example here. So here we have a function. We start with the main function. Again, one thing we didn't mention, when you write your program, it doesn't matter the increment or the user-defined function can come first before the main function, or the main function can come first before the user-defined function. So in this case, we have the main function first before user-defined function. Previously, we have the user-defined function, then the main function, then the invocation. The calling of the main function always at the end here. But the main function and the user-defined function can change place, but always record the main function at the end of the program. So here we have a function to increment, which means to add one more value. It takes an argument of n and it will increase n by 1, then it will print the n. So if n is 5, it will increase it by 1, which becomes 6, then it will print the 6 for us. So this function is called in the main method here. But before that, we have x equal to 1. So if we print before we call, s value will be 1. If we increment by 1 and we call, s value will be, instead of 1, it will be 2. So here means we are calling by value. And let's see how this works. So we have our main method or function is loaded into the memory. And the same thing applies, the statement is also loaded to the memory. The first thing we call the main method. So we go to the main method. We assign 1 to x. Then we print the value of x. Then here we are calling the user-defined function increment. Here they say what will be x after invoking the increment x. It should be 2. So I'm going to say 2. Here they say it's wrong, stay 1. Yes. The reason why it stay 1, because again, the question said before we invoke, the statement invoke the increment function is 1. Then now we are going through the function to increment by 1. And that will be 2 now. Now, after the invocation, when we call this function, we are going to print 2. The program is finished. So first again, we have x equal to 1, so we print the 1. Then when we call this function, we come to the program, increment by 1. Then we print it here. So that will print 2 for us. Then when we come here, again, it will print 1 for us. So that's the whole theory here again. Here we are starting with s equal to 4. So the value is 4, x is 4. Now we assign s to y, which means technically s also, y also is 4 now, s is 4. So this means the two are referencing to the same object. But when we increment y by 1, you will see that the reference change. The address are different now. Previously, we have, when we declare x and assign 4, we can see the address is 505.408.920. When we assign s to y, we are using the same address. They are pointing to the same memory space. But when we increment y, it creates its own memory now. It's no more reference. So we have 505.408.936. So the address are different now. So that's the concept of pass by value. Value chain, they are separate. Pass by reference means, again, they are going to point to the same object. Also here we say functions can be used to reduce a redundant coding and enable code reuse. And this is what we did in our first program. We are writing a function to find a sum of 3 different range of values. We reuse the code 3 times. The argument take 3 different range of values. So let's see this example here. GCD is the greater common denominator, which means if I have a value, let's say 2 and 6, what is the greater common denominator? It will be 2, which means if I divide 2 by 2, the remainder is 0. If I divide 6 by 2, the remainder also is 0. And that's the highest. I can use 1, but 1 is low. So we have a function named GCD, takes n1 and n2, the two values, to find the common denominator, greater common denominator among the two values. We know that greatest common denominator initially always will be 1, because if I have any two numbers, if you divide those two numbers by 1, the remainder is 0. So always we start with 1. If I have 3 and 6, 1 is, but 1 is not the greatest. I move to 2. Yeah, 2 is good if it's 2 and 6. And 2 will be the greatest because 3 is not good for 2, 4 is not good. So here we have 1. Now the possible GCD we can get is always 2. So we start the k with 2. So now we say that while k is less than or equal to n1, and also k is less than or equal to n2, what we are going to do is that if we, the GCD means when you divide the value, the remainder is 0. So here we are checking with num1. The n1, the first value modulus k equal to 0. If the n2 modulo the same k also equal to 0, then we have the greatest common denominator among them. So we are going to assign the k to GCD. Then we increment the k by 1 because we are starting from 2. K is 2. For example, if I have 10 and 12, 2 will be good. 3 is not good. Let's say 9 and 12. 2 is good, but 3 may be better because 3 is greater than 2, because 3 can go to 9 and 12. Now is 4 good? No. 6? No. Then so that's why we have to increment the k by 1 to check until we can't find anyone again that is common among the two. Then we return whatever GCD we have. So this is the method. Now here we have the test. We input the two values, enter number 1, enter number 2, then we call the method. Then the next step, again here we are using a module, so from GCD function we import the GCD. Then the next step will be our main method, which is again to print. And this is also another example. And also we have what we call the scope of variables. The scope of the variables means where the variable can be seen. We have two types of variable scope. A local variable means the variable can be seen and used in only one method, the method that it was declared or the function that was declared. Global variable means the function was declared outside the variable was declared outside the functions. So all the functions can see it or use it. So again, local variable means that very variable can be accessed in the function that it was declared. It's local, only that. Global variable, that's why it's called global. It means the function can be seen by, the variable can be seen by all the functions in the program. So if I have, for example, 10 functions, and I declare variable as a global variable, which means I declare the variable outside all the functions, then all the functions can see it. But if I declare the variable inside only one of the functions, then only that function can see it, which is called the local variable. So this is an example. You can see the global var is a global variable because it's declared outside the function. The function name is f1. So the value for global var is 1. Then we declare variable local var, which is 2. Now, if we print global var, it will print 1 because global var can be used by the function. Then when we print local var, it will print 2 because it's inside the function. Now, outside the function, we have the invoke. Then we print global var. It still will give us 1. The value will not change. But to print local var, we can't. This will give us an error. Why? Because local var is outside the function right now. It's supposed to be inside the function because local var variable was not declared in this range outside the function. It's only inside the function. So print local var will work only inside the F1, but outside the function to not. But global var will work inside the function, will work anywhere outside. So another example, s equal to 2, we have a function and we change the s value to 2. We start with s equal to 1. In the function now we have s is equal to 2. Now if I print this, it will print 2 because it's not saying the outside x, which is okay. Even the names are the same, but F1 x here cannot be seen outside. So if I say print s, it will display 2. Now if I come out of the function and I print x, it's going to print the 1. It's not going to print 2 because that's what is seen outside. So again, the difference between local variable means a variable that is declared inside a particular function and it can be used by only that function. Global variable means the variable is declared outside the function and it can be used by any function in the program. So we have another example. We tell the user to enter a number. Then we say if the number is greater than 0, then we assign 4 to y. Then we print to y. Now what is happening here is that the y was inside the if condition. It's not outside. So if I say print y here, this will give us an error unless I have y outside the if. So like for example, the input we enter was y, or let's say we have some y outside and declare the variable y, then there will be no error. But in this case, we are going to, unless we write the print y inside the if statement, inside the if, which means we have to type it once so that the if statement will affect y. Because inside there, we already assign y. And if we do that, then y will print, if the condition is true, it will print 4 as y. But at the moment, we can see the print y is outside the if condition. So it's not going to work. We get an error. The same example here, we can see the I is inside the for loop. And we had everything. Then we say we want to print I will not print. We get an error. We can print sum because we can see we declare sum outside the for loop. So print sum is okay. So in order to print I, we have to declare I outside the for loop. But in this case, we get an error because I is out of scope. It's inside the for loop and the print is outside the for loop. Unless the print I is inside the for loop, then it will work. Another example here, we have x as a global variable. So we have our global x, we had 2 numbers, then we print x. So this will work because x is a global variable. Increase can use the x. So it will give us 2. And when it gives us 2, we call the print s outside. It will still display 2. The reason why, because we declare x outside and we use it inside the function we came out. So it's a global variable. It will display 2 instead of 1. So we can also have a program to generate a random characters. So let's see how this works. And the whole goes again is previously we write this code, but we write it as a one program. But here we have again different functions. So first function, is going to generate a random character between ch1 to ch2. So the function name is get random characters ch1, ch2, and it will return the run int, the order from ch1 and ch2. Now the second one, we are going to generate random lowercase letters, so from A to Z. And the third one, we are going to generate a random uppercase A to Z. Also, we're going to generate digit values from 0 to 9. And then generate a random character also from 0 to 127. That's the universal, the ASCII, the universal code. So what are the benefits of a function? As we saw, I think the first one is very important. I can write one function and it can do many work as far as it's doing the same thing. For example, we saw the function to find the sum of numbers from one range to another. It can be from 1 to 10, 20 to 30, 40 to 50. It doesn't matter. I'll write only one code and I will use it to find all the different ranges. So write a function once and reuse it anywhere. Also, information hiding, for example, the scoping, variable scope. If I declare a variable inside a function, only that function can use it. So it's more secured. So we can hide some values. So hiding the implementation from the user. And also reduce complexity. It makes our program more organized also. Very organized. So again, wish everybody the best and see you in the next lectures. Thank you.